Alright, so welcome to a second video this week, and we're going to start target 12. I can find the derivatives of trigonometric functions. And the whole purpose of this is I want to show you the proof of how to do it. We're not really necessarily going to have this be a large part of what we have to do, but I want you to see the work behind it. And so that's why I'm doing this in proof method. Now, why are we doing this? Derivatives of sines and cosine play a key role in describing periodic change. So if something is periodic, if we can find the derivative of that function, we can find how fast it's changing at instantaneous points. So we'll use the limit definition to find the derivative of sine. So our limit definition, y prime, will be the limit as h approaches 0. Remember, we do f of x plus h, so that'd be sine of x plus h minus sine of x all over h. Now, right here, that is a trig identity. You'll need to have your trig identity sheet out. You'll need to know your trig identities to simplify this. That simplifies, it's an angle addition formula. That simplifies to sine of x cosine of h plus cosine of x. Sorry, that's a funny looking x. Cosine of x, sine of h, minus sine of x, still all over h. Now what I'm going to do is rearrange it so that my sine of x's are together. Alright, so I'm just going to rewrite this. Just changing the order, same exact stuff. The limit as x approach is 0, sine of x, cosine of h, minus sine of x, plus cosine of x, sine of h, again all over h. Now as I simplify this, the first two terms both have sine of x in them. So I'm going to factor out the sine of x. I'm left with cosine of h minus 1 plus cosine of x sine of h. Now I'm going to use that fraction trick where I split the fraction into two fractions with a common denominator. Now as you look in this piece, right here is a trig identity, a special trig limit. That approaches 0. And since the variable in question is h, this stays the same. This approaches 0, so it's sine of x times 0, which is 0. We can ignore. Right here, as h approaches 0, that approaches 1. So this part cancels off, and the derivative of sine is cosine. That is what you need to know from all this. Now the limit definition, that's bonus. I would definitely take a look at that and make yourself familiar with it. But the whole idea is, if the function is sine of x, the derivative is cosine of x. Summed up nicely right here. The derivative of sine is cosine. Alright? Let's do the same thing with cosine. Find the derivative of cosine. Alright? So we'll use the limit definition. We'll find our y prime, or dy dx. The limit as h approaches 0, we got cosine of x plus h minus cosine of x all over h. Use our angle addition formula. If you're not sure, check the board on Monday. Cosine of x, cosine of h, minus sine of x, sine of h, minus cosine of x, all over h. Right? Again, I'm going to put my cosine of x's together. So we got the limit as h approaches 0. Make sure when you're doing these, each step's equal, so that limit needs to come through. We're going to put our cosine of x's together. Cosine of x, cosine of h, minus cosine of x, minus sine of x, sine of h. Again, I'm going to split the fraction. The first fraction, I'm going to factor the cosine of x out. So we got the limit as h approaches 0, cosine of x. That's cosine of h minus 1 over h minus sine of x, sine of h over h. And as we evaluate this, here that's that special trig limit. That's 0, so this part cancels off. There's the other special trig limit. That's 1. And so what's left is the negative sine of x. So the derivative of cosine is negative sine. That's all I want to get you to get from this video, is those two ideas. Derivative of sine is cosine, and derivative of cosine is negative sine.